So first part of it, section 12.1, talking about these sets. So this is the universal set. These are all the possible choices for these problems. And then we got P, Q, and R. So what the first problem is asking, I'm glad you're watching this review, by the way. Congratulations on good study habits. The first thing we got to do is work inside here. So I got to try to take Q, intersect with R. That means I got to look at everything that both Q and R have. So I'm going to do that first, and I'm going to say to myself, all right, what do Q and R both have? 2, 4, 6, 8? No 2, but they got 4, 6, 8. So both sets, that's like the word and. If I'm asked, you know, what does this symbol mean? This symbol means that I have to take whatever elements are in both of the sets and create a set, okay? But this symbol here, if I'm asked what this symbol means, that means that I take the union or any elements that are in either P or this new set. So my final answer to this is, well, look at P and look at this new set. Anything you see makes it to the final set. So the first number, chronologically, we see is 3, but then we have 4. We also have 5, 6, 7, we have 8, and we have 9. So this is our final answer when we consider set P or the intersection set, which was 4, 6, 8. Okay? Now, if I'm asked what this symbol means right here, that is the complement of Q, but what it actually tells me to do is to look at set Q, 2, 4, 6, 8, and look at the universal set. But the complement of Q here is everything that's in the universal set, right, but not in Q. So that means starting off with 0, we have 0, 1, I don't include 2 because it's there. So I'm going to do 3, I don't include 4, so I go to 5, 7, and then to 9. That's all the stuff, all of the elements that aren't in Q but are in the universal set. All right, we're going to intersect that with, but I can't do that yet because in parentheses here I got to do the P union R. So when I look at P or R, so I'm going to intersect this one, that's the intersection symbol, but P union R would be 3, 5, 7, 9, and 1, 3, 4, 6, 7, 8. So as long as I see it once, it makes it. So 1, 3, 4, 5 is in set P, 6 is in set R, 7 is in actually both of them, 8 is in set R, and then 9 is in set P. So all of those. So what's in common? Let me see if I can use the highlighter here, be fancy. All right, what's in common? We got 1. Whoa, I'm not fancy. Sorry. Okay, let me back it up. Go yellow, highlight a little bit larger here. There we go. So we got 1 in both of them. We got 3 in both of them. 5 is in both of them. 7 is in both of them. And 9's in both of them. So everything I highlighted there would be in the final answer. So the final answer here to the intersection, 1, 3, 5, 7, 9. Alright, so hopefully those are making sense now. Alright, well, sorry. Let me undo that. I'm having a hard time here. There we go. Alright, moving on to the next one. Just getting a little bit more complicated here now. Is that at the end of this one, what I want to do is take the complement. So this big old bar here just means take the complement at the end. So what I want you to think about now is just simply doing this. The complements don't cancel each other. Let's just do the complement of set P. So the complement of set P is actually equivalent to, if we look here, everything that's not in P. So 0, 1, 2, 4, 6, and 8. Okay, that's the complement of P. But now I'm also going to do this one here, Q and R together. Q and R together would be, let's see, 2, 4, 6, 8, 4, 6, 8. Okay, we actually already did that one earlier on number 1. So 4, 6, 8. But now I have to do it slowly. I did the intersection, I did the complement. Now I'm going to do the union of these two new sets. So the union of these is actually here, everything we see. So 0, 1, 2, and then 4, 6, 8. But now is when I do that final complement right at the end. So I'm doing the complement of this one right here, of this set. So the complement of that would actually be starting with 3, 5, 7, and 9. Okay, so that would be the final answer to this problem. A little tricky, you just got to take it slow in progression. All right, so they're asking me to find the intersection of P and Q. Well, if I look here, I got 3, 5, 7, 9. And I look at Q, I got 2, 4, 6, 8. We pretty quickly see that there's nothing. And there's two ways to show that. You can just literally show this. This is an empty set. It means there's nothing in common between those two. Okay? Or you can show that by saying like the null set. Like that's another way of saying it. Okay? Just don't put that inside of here. That's not the correct way to say it. All right, so going down now, what is special for P and Q? Well, they don't have anything in common, right? So that term, which we use for those two sets, they're called mutually exclusive. Okay, when the two sets do not have anything in common, or you could call them, another thing is they're disjoint. Okay, two ways to kind of describe that there's nothing in common. All right, so here's the deal. If there are 42 elements in the sets of A and B, and then 16 elements, so now we're going on to new ones, we're not using the ones up above. 16 elements in set A, 14 elements in the intersection of A, how many are in set B? All right, well, hopefully by now you kind of got this down. You take all the number of elements in set A, and I'm not, here I can write it out better I guess. Take all the number of elements in set A, add to that the number of elements in set B, and subtract from that the number of elements that are in A and B. And what that will do will give you the number of elements that are in A or B. Now let's see how this works for this problem. So it says there's 14 elements in the union of sets A and B. Whoops, sorry. So that's right here. I don't know what's going on. Hold on. There we go. All right, so that's on the right side. So there's 42 in the union of sets A and B. 16 in set A, so I'm going there, plus they're asking us to find this, so the number of elements in set B, but minus 14 elements in the intersection, so we do this here. Okay, so what do we really have over here? We really have the number of elements in set B. Well, what's 16 minus 14? We're sitting there at 2. Subtract 2 from both sides. The number of elements in set B is 40. And I want to visually show you on this problem how that kind of makes sense. If I have an A here and a B here, look at how this kind of follows. The intersection was 14. So when we do Venn diagrams, we like to start with filling out the intersection. Well, all of set A is 14. So, or I'm sorry, 16 right here. Okay, all of set A is 16. That means we only put a 2 out here because the entire number of elements in set A has to be 16. All right, well, set B, like we just found out, has 40 elements in it. So what we have here is a 26 because 26 plus 14 makes the 40. But if you look at this, 26 plus 14 plus 2, if we add all those together, that equals 42. That's all the elements in A or B. So you can kind of think about it Venn diagram, think about it counting formula. It should work either way there. All right, moving on to number 7. Sets A and B are mutually exclusive. Now, what does that mean? It means they don't have anything in common. So if you think about this right now, very simple. The number of elements in set A, right, plus, well, I'm not going to write it all down again. It's right there. That's the formula, okay? So let's back up here. 33 plus number in B. Well, guess what? That's what we're looking for again. And then minus 0. They're mutually exclusive. They don't have anything in common. So that's equal to 122. Okay? So all you got to do is subtract 33 from both sides. Okay? So we have here the number of elements in set B equal to, sorry, show my work here, minus 33, right? So we have here, sorry, pause there for a second, 89. Sorry, 89. So the number of elements in set B is 89 because they're mutually exclusive there. All right, moving on to this next part. Remember, when we set up these Venn diagrams, these ones that we've been working on, they're triples. Okay, so there's the triple Venn diagram. And you got to set them up as, all right, the 3 things we have. We got work study. Okay, so I'm going to call that one work study. We got ourselves loans. All right, there's loans. And then we got grants. All right, so work study, loans, and grants. We start from the bottom and work up. So what do I got here? I got 4 who used work study, took out loans, did all 3. So that goes right in there. Okay, but the next step is the key step for most. 11 used the work study program and took out loans. So work study, loans. There has to be 11 right in here that I'm indicating. We already have 4. If you put an 11 right there, that would mean there's 15. So you can't, you have to subtract, and that's where you get the 7 from. So I've got 4 and 7, 11 total between those. Okay, so we've taken care of this, we've taken care of that. Now go up to 10, grants and loans. So grants and loans, so that means we put a 6 here. And then work our way up. 16, work, study, and grants. So that means I have to add 12 more right there. Okay, and now we're ready for the last part. 34 use the work study program. So right now, if we look at this, we have 12 plus 4, 16, plus 7, we have 23. We need to put 11 more there because now there's 34 that use the work study program. Same with the grants here. 10, 22. We are missing 15 to make the grand total of 37 grants. And then 33 took out loans. Well, I got 10, 17, so I got to have 16 more over here to grand total up to 33. And now let's add all these together. What do we got? We got 15 plus 6, 21, 25, 37, 48, 55, 65, 71. There's 71 total if we add up all those numbers. Well, 87 people actually were surveyed. So if we have 71, 87, and then you take away the 71, okay? So that's where we're getting 16. What's the 16 represent? Not taking out anything, okay? None. So when we start answering the questions now, we should all be looking at the same Venn diagram. So how many of the surveyed sophomores have a grant or are in the work study? So what I'm going to do up here is I'm going to circle some stuff as I go, and I'm just going to erase it afterwards, but I want to make this crystal clear with this yellow pen here. Survey have a grant or are in the work study. Who's saying yes to this? They are. They have a grant. They have a grant. They have a grant. All that there, all this here, and all that there. All of those people that I circled have a grant or are in the work study program. Okay? They're all saying yes. So when we add those together, we get 21, 25, 37, 48, 53. So this answer is 53. I can't deal with that color there. 53. Okay? So let me go back. That's going to take away my 53, I just realized. All right. So I got 53 here. All right. So moving back to here now. Answering the next question. How many surveyed sophomores do not have loans or grants or use the work study? I don't have to circle anything. I already got that number. That's 16. So I got 16 sitting right there. How many of the surveyed sophomores have loans only? Loans only, loans only. The only people saying loans only are those people right there. So that's also 16. How many of the surveyed sophomores had neither grants nor loans? This is the one kids mess up on because they forget about something. But guess what? If you ask them all, do you have no grants and no loans? All of these people right here, like they're going to say yes because they have grants, loans. All of these people are unsuccessful for this scenario. No grants, no loans. That will be 11, but don't forget there's 16 over here. So the answer is not 11, it's 27. There, I did it again. Let me erase all this and then put the answer in. So 27. And then last question. How many of the surveyed sophomores use work study or have grants but didn't take out loans? All right, so here we go. Let me take green here and I'll circle. Work study or grants. Okay, work study or grants. Work study or grants. Work study or grants. Work study or... All of these are work study or grants. But then there's a stipulation. But didn't take out loans. Okay, well that gets rid of these 7, these 4, these 6. So how many are left there? 15, 27, 38. So the answer to that one will be 38. Okay, I'm going to actually stop this video here, and I'll pick up on number 13 on a different video.